tools you will need to be familiar with as you use this software. Then you have the display window, and of course you have the notes and the log files. CAD files accepted by Moldflow. Most native CAD formats such as plastic injection and compression mold simulation for design and manufacturing. What is Moldflow? Moldflow simulation software lets you troubleshoot problems with plastic injection and compression molding. Advanced tools and a simplified user interface help you address manufacturing challenges such as part warpage, cooling channel efficiency, and cycle time reduction. Now let's look at the user interface. Here you can see the project pane, the study tasks, the layers, the environment toolbar. The environment toolbar holds most of the tools you will need to be familiar with as you use this software. Then you have the display window, and of course you have the notes and the log files. CAD files accepted by Moldflow. Most native CAD formats such as the normal Autodesk for architectural designs, SAT, SEPT, IGES, STL. Then it also supports parts from like ANSYS or SolidWorks. Then of course it also accepts assemblies. We'll be talking more of these in the future. Mesh tabs accepted by Moldflow. You have the .mfl, then CMOD, CMF, the Ideals Universal, that's .unv, ANSYS Prep 7.ans, Nastran, NAS, Nastran bulk data, BDF, Patchers, .pat, and FEM, respectively. It also has a whole lot of models you can choose from. You see, you have the stereography. You have the Moldflow, the MFL, the Moldflow 3D, C-Mode, Autodesk Inverter Parts, Autodesk Inventor Assembly, Inventor Parts, Moldflow Study Files, that's .sdy, MPI 2.0, projects. Then of course the Moldflow.pn. Ideals Universal, ANSYS Prep, Nastran, and so on and so forth. What is a design of experiment? Virtual DOE, Moldflow Insight, Premium or Ultimate gives you the answers to why do you have to simulate. Firstly, it enables you to multitask. Secondly, it provides very few steps to set up. In person, it saves you thousands, if not millions of US dollars or capital. Then, of course, once the press staff time is, estimated, the wasted material is also put into context. The metrology resources, then of course, give you the data. Then influences on global weighted quality, dimension, scale factor, the mold surface temperature, the packing pressure, the melt temperature, the injection time. The injection time seems to be a very, very important variable that you get used to with time. VP switch over by volume field, packing time. Now, why are we running this Moldflow analysis? These are some of the basic research questions that you should have for each use case. All right. Firstly, you ask yourself that will the part fail? What material should be used? What optimum processing, or what are the optimum processing conditions? Where should the gate be? How many gates are required? Where will the wheel lines be? Are there air traps? How thick should the part be? Is the flow within the part balanced? Are the ribs too thin to fill? Are the ribs too thick? Can the part be packed enough? Will the snap fit break? Is the press big enough? Are the runners balanced? What size should the runners be? Can the runner volume be smaller? Is the gate the right size? Is the cooling uniform? Will the part wrap within tolerance? Now, let's look at some of these things that you'll be encountering in the future as you use this software. You have the analysis sequences. The analysis is a very, very important part of the Moldflow, Autodesk Moldflow software. Now, you have setting up the tool, analysis wizard, you have results, and then you have tips and tricks. Now, let's look at these analysis sequences. In the analysis sequences, you have the design advisor, the gate location, the molding window, the runner advisor, the runner balance, the cooling quality, the field pack, the wrap, the code, the sync map. Then, of course, you have the dual domain or the meshing. You have the shell, thin wall. These three options are actually what you'll be encountering when you bring in a new part into the Moldflow software. So usually before you be able to mesh within the Autodesk program, is recommended you set the incoming parts as a dual domain, okay, because it enables these two properties, the shell and the thin wall parts. Then you have the 3D solid thick wall parts, complex geometry. Then you have mesh not visible, accuracy setting in process settings wizard. Then of course you have the setup options, the part only, the single cavity and multi cavity respectively. Then process for setup, set analysis type and apply injection location. This is very important. You need to set the injection location when you are producing simulation under the software. Use the ribbon. You can see the left to right for setup geometry tab. Then if it is grayed out, that means you need to ask yourself this question: is it a part only, or are you trying to do something else? Okay, so what you need to do is you try to add injection cone and add the parting plane so that those parts will not be grayed out. Now let's talk about the mode creation. Orientation is very, very important. Okay, XY plane for surface area. When we go into the practical aspect of using this software, you've seen a whole lot of this. Parting the line determines the end of the gates. Okay, drag red boxes or use properties dialog to specify coordinates. Yeah, like you can see there, the X, Y, Z, that gives the ability to for a three-dimensional view. Now, feed and pulling systems. Use wizards, draw manually or import custom databases. Now, understand system databases. Note, take care when editing the default properties. It is easy to create nonsensical processing condition. It is usually safer to create a personal database with a copy of the default properties. Okay, so then you can see we need there some of the properties, the edit default properties that will bring this dialog for the properties, enlarge version. When you see the thermoplastic injection molding solver parameters, the injection molding solver parameters, the reactive molding solver parameters, RTM, SRM solver parameters, and so on and so forth. So these are kind of models that enable you to do your work, your molding process, and your simulation faster. Now let's talk about the Synergy customization, Synergy API. The Synergy API is an object linking and embedding OLE programming interface that enables certain functionality to be automated. The API supports different programming approaches: the Visual Basic Script, that's the GBS, the JScript, and other programming languages. Then Visual Basic for Applications, VABA, as part of Microsoft Office Application Suite, Visual Basic VB. Then you have Python and so on and so forth. Now, the functionality of the API has certain known limitations. Some functionalities are intentionally locked out, material database access. Some functionalities can be used in a script, but they are not captured by micro. Reverse engineering through example provided with Synergy. Autodesk Moldflow 2023, what's new? Now let's look at some of the features of this software, the 2023 version. Easier to manage and install. Combine installers from Moldflow Advisor and Moldflow Product. Install all components at once. Named user product offering. More flexibility. New simplified offering. Includes Fusion Scene extension for Moldflow Advisor. Okay, for the named user. Now, license time for feature, especially useful for Flex. That Flex is, the Flex seems to work with the license, so that you can actually do your analysis, and then The Simulation Compute Manager also uses these features, these softwares, these add-on softwares for the simulation to go smoothly. Now, shrinkage compensation results. Under the productivity and workflow, you have the shrinkage compensation result property applied only on visible cavities, useful for multi-cavity moldings. Three-dimensional grill element for faster analysis of sockets and speakers. Enhancements for mid-plane injection. Compression, time series thickness result allow final thickness to be less than the normal design thickness. Improved 3D surface meshing speed on large complex models with many CAD faces. Solver API enhancements to support user HTC and heat source options. SCM, that's the Simulation Compute Manager. Updates provide improved cloud solve performance and robustness. Okay, that's all about that under the productivity and workflow. So let's now move to the technology leadership and accuracy. Improved accuracy for 3D wrap, particularly for materials which low modulus or high poisonous ratios. Okay, so improved 3D fiber orientation prediction in core layer. Improved wrap MDDD accuracy, symmetric deflection or on symmetric parts by improved automatic constraints. Improved cool boundary element accuracy when cooling circuits or feed systems are close to the part surface. Improvements to 3D sync mark predictions. New updated Scandium Tech preview. Then of course you have the Scandium Tech review. Stamp 3D warpage improvement for on-field materials. Anisotropic thermal conductivity. 3D flow, particularly useful for high conductivity fillers such as carbon fibers. So let's move to the user interface. 3D meshing improvements. 20% speed improvements for 3-dimensional tetrahedral meshing. Advisor 3D meshing upgraded to advanced layer meshing technology, same as Insight. Okay, the Advisor, the Insight, and the Synergy, they almost are the same. Now, fix problem of bad mesh structure for fine surface mesh. Okay, as you can see, the Advisor 2021.2 and Advisor 2023. All right, there is a great improvement between those two versions, as you can see some of the examples given there. If there is a bad mesh structure, you can actually correct it under the Advisor 2023. Now let's look at the solver improvements. Improved 3D to fiber orientation, improved transverse orientation prediction in core layer, long glass fiber PP orientation in flow direction, and then of course the measurement location. You can see now the X and Y axis, you have the orientation in the Y axis, and you have the thickness direction in millimeters. So this should give a specific graphical outline for the solver improvements. Okay, talking of the typical example of an experiment between using the 2021 version of 2 or the 2023 respectively. Alright, so here's our references. You have the introduction to plastic Moldflow design, 62 pages. You can also Google that up to get access to that particular book. Then you have the Autodesk Simulation Moldflow Plastics Made Perfect, about 10 pages. The GE Engineering Thermostatic Design Guide is about 292 pages. Then you have Simulation and Design of a Plastic Injection Mold, a joint mold for credit card and USB holder by Samsung Telecamos. Now, Injection Molding Handbook, 3rd edition, edited by Dominic V. Rosato, P.E. Donald Rosato, PhD, Marlene G. Rosato, P.E. Now, the 6th reference we have is the Intelligent Optimization of Mold Design and Process Parameters in Injection Molding by Nedhi Mohahiden. Then we have the Moldflow Design Guide for Resource for Plastic Engineers, 1st edition, edited by J. Shoemaker, Moldflow Corporation, Framingham, Massachusetts, United States. Then you have the Plastic Injection Molding, Mold Design and Construction Fundamentals by Douglas M. Bryce, Volume 3, Fundamentals of Injection Molding Series. Practical Guide to Injection Blow Molding. Professor Clemson, University, Clemson, South Carolina. Roller and Gating Design Book. Tools for Successful Injection Molding. So that's about all.